So this is the cables you get with it. You get this XT60, it looks like, to Anderson. Nice quality cable. You have a nice heavy duty plugged jack. I do like that they put this EMI interference thing on this cable. That's kind of interesting. And we have the certification and the instructions. Let's read over the instructions really quick. It looks like registration thing and portable user manual. Let's quickly look it over. BLUETTI, blah, blah, blah. Safety instructions on, off. Let's see what we have here. Grounding instructions. The product must be grounded when connected to the grid. With AC charging, having equipment grounding conductor. Improper to the grounding conductor can give you issues, I guess. What's in the box? There's a grounding screw, apparently. I don't know what's that for. Apparently you could do a grounding thing. That's the information over here. I'm doing it for you guys, so that you guys could see what's exactly there. Powering it on is in the middle. AC on, off, press AC button to turn on. DC on, off. Okay, charging options. Blah, blah, blah. Plug it into the wall outlet. Fully charged. So it looks like voltage open circuit 12 to 60 volts, 1000 watts max. That's one of the reasons I got it, was the 1000 watts max and the 20 amps max over here. That's interesting. So we got to see how it charges with 20 amp. Let's say from a 12 volt battery, because that means it could probably charge at 240 watts. 20 volt 10 amp panels, then one should be okay. Car, make sure it's running to make sure it's not okay. Connected. Charger, power, AC outlets, so 1800 watts max. DC outlets, so we got a 12 volt 10 amp, 12 volt 5 amp per port, 100 watt 100, so that looks like USB-C, and 5 volt 3 amp. So two regular dinosaurs. This is where you plug in your dinosaurs. Configure settings, enter mode, press and hold. So P006, it looks like this is one of the reasons I got it. I think you could turn off the Wi-Fi. Charging, so solar input, so standard. Note, battery friendly. So if you want to battery friendly it, you want to do the 600 watts max charging. Power lifting mode, so it could do up to 2700 spikes. Make sure it's not pure resistive loads. Eco mode. Device information. So it looks like you get some device information. UPS feature. 10 milliseconds. Okay. So if you guys want to get this stuff tested, watch the other guys' videos. Right now we're just looking over the manual here. So by reading the instructions, we actually understand it. Grid adaptive mode. If consumption power exceeds charging, enable this mode in the app. The lead 1V2 automatically adjusts to handle power fluctuations. Okay. PV priority. Okay. So that's really cool. If you have a solar panel connected, it's going to use your solar panel power first until it hits like 20% or something, and then it turns on. This is really cool. I do like this part because once it runs out of the power, so it's always trying to focus on using the power from the solar panel first, and then after that using the power from the grid. I do like that. So that this way you could save yourself electric costs. Oh, you can actually schedule the load. That's cool. Wow. It has a lot of cool stuff. Recharge the unit before charge to 40, then power off and disconnect all cables. Store in cool, dry place. Fully cycle every 3 months to maintain battery health. Avoid extended storage. It may impact performance. Shut down, charge within 48 hours. Specifications. So 1 kilowatt, it's 25 pounds. So we got a 12 volt, 10 amp, 15 watt USB A's, one USB-C, that's 100 watts, one USB-C, 140 watts. That's really cool. That could charge a MacBook Pro. So you could technically charge 2 laptops. 140 watt MacBook Pro, that's pretty cool. AC plus DC output is 1900 watt. AC charging, 1200 watts max. AC input, 1800 watts max. Charging plus bypass. DC input, 1000 watts max, 20 amps max. So I think at 12 volts, so you could charge at 240 watts. Switch over less than 10 milliseconds. Log in, so that's the BLUETTI app. So I think you have to register an account, bind the unit, connect via Bluetooth, check firmware updates, so you could update the firmwares through the online thing. Grounding guidelines. Only use the grounding terminal when product is connected to the home grid using a 2-pin cable, or if the wall outlet's grounding is ineffective and the connected device features a metal case. Using a cable OT terminals. Okay, so that you could do a separate grounding. Okay, so that's what the idea was with the separate grounding. FCC statement. Device may not cause harmful interference. Recipient receive camera. FCC IC caution. Okay. And that's their email and phone number to get in contact with them. Okay, so that's really good instructions. Let's get the unit out. Let me pull it out and we'll continue. So that's the unit. It looks really cute. It has a little carrying handle on the back. That's what the information is on the back. It says here. So 5528. So it says 5 amps per port, but 8 amps max. So I guess if you're using both ports, 8 amps max, or you could do 5 amps from one port. 10 amps from the cigarette plug port. And we got 2 nice USB-Cs. That's nice. DC/PV, 12 to 60 volts, 1000 watts. So it could do 1000 watts, 20 amps max. Nice inverter. It has these cornered plugs. So I don't think any of these outputs could be more than 1800 watts. Most of the time, 1800 watts is more than enough. But I think it's 1800 watts across all devices. So if you're using two 120 and a 240 and you're trying to cook a hot plate, it might not work so well. We have the PV input on the front. I do like that it's in the front so that you could put this kind of like in the corner. I do like that it's 25 pounds and carryable. I do like that it has the 2 fast quick charge laptop charging ports. I do like the separate DC plug. Let's see, turn it on. So it's a 28% charge. The DC goes on like this. So right away the fan turned on. And then it turned off, I guess, on. Very easy to plug in. I don't think the actual Wi-Fi is automatically on. I think you have to hold the button in the front. So what we're going to do is we're going to take this, I guess, outdoors and check it out. I have a 200 watt solar panel to test with it. And then we'll see what it looks like and feels like charging from solar. So it's a nice, I would say, smallish portable unit. I do like the capacity. It uses a 52 watt-hour battery, 51-volt battery. And that's going to be kind of interesting to see how it charges from the various different sources. I'm excited to see. Okay. So connected to a 12-volt battery. See, I connected with an adapter from Anderson connector to this. It's doing 97 watts. So it is 12 to 60 and it is 20 amps max. However, it seems that it's 20 amps at a slightly higher voltage. Maybe it's just ramping it up and it's realizing that it's 100 watts input if it's that low of a voltage. So we're gonna check with a 20 volt solar panel if it's the full 20 watts max. So if you're charging this from your car system, even though it's 20 amps max, it sounds like the algorithm is set up to be charging it higher than 20 amps. So this simulates connecting it to your car battery system. So it detects the voltage. So that's the max input that we can see for a 12 volt battery system that this guy could input. So testing it out with this 200 watt solar panel, I'm getting about 94 watts out of it, 93. There's already shading on the corner. This is the only daylight I have left. Long story short, it does work with the charging. I think that's a 20 volt solar panel. So probably if I parallel two solar panels at 20 volts, 400 watts, long story short, if it's two solar panels at 20 volts, it should probably be able to pull like 160. Let me get to the conclusion here. So we have the BLUETTI app on top. Register as a BLUETTI member. For long-term storage, do 4260. What do I like about this unit? I do like that it has the DC plug. The anchors, what's really sucks about the regular anchor ones is they actually eliminated this part and only left the plugs. And I don't think it had enough USB-C ports. This one, I like, it has all the USB-C ports you need to charge like a laptop. Very easy to connect. So it's probably 20 amps max when it's above probably 30 volts, I'm guessing, because we could test that pretty easily. At a 12 volt, it's not going to take more than 100, and with a 200 watt panel that's already getting shaded, that's the kind of power input you would get. So you would probably put two of these solar panels in parallel. The goal is to actually have a easy to use solar system that you could throw this in the back of the car. 25 pounds is reasonably easy to pick up. Charge up your drone, charge up your laptop, stuff like that. What I also like about it is that it doesn't seem to have the Wi-Fi Bluetooth turned on right away. You have to go in the settings, and I think you have to hold this button or something, or hold the other button. Oh, holding that turns it off. Okay, holding that turns it on. So I have to look at the manual. So in order to turn on Wi-Fi Bluetooth apps, you would have to do it. I think also it's set on eco mode, so most likely maximum is going to charge maybe is at half. Two USB-C ports. This was pretty reasonable. I think this was about $300 something, or maybe 400. Mind you, a battery pack just by itself, that's a kilowatt, is about $200. It depends on the brand you're getting, $200 to $250. So for $100 more, having all this stuff and having a carrying handle and having a charge controller already plugged in, I think that's really awesome. Overall, I would recommend it. Plus, you could run a coffee maker with an 1800 watt output. So that's what I like. You could pretty much run any appliance, probably a hot plate, charge right off the solar power. 1 kilowatt of energy is not that much, but if you really think about it, if you charge up a 48 volt battery and connect this to here on the input, if you connect probably a 48 volt battery, you could probably get a full kilowatt of power in there. Almost 48 volt would be 50 something volts at 20 amps. So most likely you would be able to get a kilowatt of power. So if you have a separate 48 volt system, quickly connect this and then charge off there, and you're not going to be limited by the input power of this, use the BLUETTI's 20 amp MPPT charge controllers and have your use this as an inverter. Because if you really think about it, a 2000 watt inverter is between $150 and $200 anyway. So just for an inverter, but you don't get the charger, you don't get these 12 volt output. You pretty much get everything you need to run an off-grid system with this. Plus, at about 100 watts, you could always be keeping it topped up even with a 12 volt battery. So if you have something like a fridge running, you could top up the 12 volt battery with a bunch of parallel solar panels. And yeah, it's going down because it's getting really shaded right by the moment. Oh, so overall, I do like the screen. I do like the version. I do like that it doesn't have the app turned on by itself. I have to figure out how to change the things. So would I recommend it? Yes. Thumb up to the channel. Link down below to the Amazon listing. It's an affiliate code, so I would get a kickback. That's how you would support the channel. I'm just like a buyer like yourself, just testing things out. This review is unfiltered. I didn't cut any parts out. As I opened it, I'm giving you what I thought. I ordered it a couple of months back on a Black Friday deal. So I don't know, it was $100 off or more. BLUETTI is a really competent brand, so probably good with the warranty. Hopefully I never have to use the warranty, but if I did, that's really nice. I like the compactness of it. I like that you could probably keep your MacBook Pro running for days with this. So most modern laptops without a graphics card actually would use these USB-C ports. So that's probably much more efficient than running something off the inverter. But if you need to make a coffee, you could also use the inverter for the coffee thing. Probably could run a crock pot off it, but it would probably run out before because it's only a kilowatt. But if you connected 48 volt on the input, a 48 volt battery with a solar panel to recharging it, then you could probably use the inverter all the time because you're gonna have 1,000 watts coming in minimum. And even if the crock pot uses 1,000 watts, you would always have a little bit of reserve to keep the pure sine wave inverter running. So overall, I think it's a cool buy. I like having more solar generators than less because, you know, power systems, the more you could be self-reliant, the better it is. Okay, friends, see you guys in the next one. I hope you guys found my review interesting, and yeah, check out my other videos and thumb up and subscribe. Bye. So plugging this bad boy in, I just plugged it in just a minute ago, and what I noticed, because it's set to economy mode, it actually hasn't kicked on a fan yet. So that might be the solution to it completely being silent. Apparently it's going to charge up in 1.3 hours from 30%. Well, because it's only a kilowatt electricity, so perhaps maybe that's the better way to run it instead of running the fans at full tilt. That might be actually a beneficial power of it because it's set to economy right now. Eco on the top over here, you see? And it says over here grid is connected to the grid. That's kind of interesting. So the fan actually just kicked on now, and reading the manual, you see over here this part. So self-consumption. Inverter efficiency is 85%, and the self-consumption is about 10 watts. So it looks like we have a very, very efficient inverter on this. That definitely is giving a positive motivation to me. That's pretty cool. I do like that. That 10 watts self-consumption, that's really nice. You can leave the inverter on and not worry about it. The cool thing about Eco Mode over here is that it's enabled by default and shuts off AC or DC output after a period of low or no mode. AC Eco Mode is not available when charging with AC power. Press the Eco Mode button to turn on/off DC modes together and use the BLUETTI app to control them separately. Disable eco mode when connecting small devices under 60 watts or critical appliances such as lights or refrigerators. So guys, remember to disable eco mode if you're connecting your fridge to this. So apparently you press these two buttons together to get into the settings mode. So we don't have the Bluetooth and Wi-Fi enabled right away, which is really cool. And let's see. Page 1, and then page 3. Page 1, okay. Let's see what this means. I do like that it's charging at no sound. Let's see. How do we change the setting again? Enter mode. Press and hold AC and DC buttons simultaneously for about 2 seconds. Then the frequency icon flashes. Exit mode. Press and hold the AC and DC powers again. If idle for 1 minute, it will automatically switch. Turn off AC output before doing the settings. And then, okay, so let's see. Page 4. Eco. Okay, so this one switches the page, the left one switches the page. And then the icon that you're switching on and off is on page 7. So I just turned off economy mode, so it doesn't turn off anymore. So let's see. Page 7, page 1. Okay. I got a feeling I should have this instruction manual close by, or stuff like that. So there's 3 different modes. How do I change this? Offers 3 AC charge modes. Standard, turbo. To use the app to activate silent mode, and use the app to activate... Oh. So silent mode. So I think it might have actually silent mode on by default. Because see, there's standard, which is 600 watts. I do really like the quietness of this. I don't know if it's my PC over there or if it's this guy. Yeah, the fan is barely running. So charging 600 watts, it's barely running. So you're not going to overload your system using that system. It is nice to do the 1200 watts. And it looks like the charging mode can only be activated inside the app. So you probably need to enable the Bluetooth or Wi-Fi stuff in order for the app to work. So AC echo and DC echo modes are enabled by... AC echo mode is not available when charging with AC power. Press it to turn on and off echo and this DC echo. Okay. So that's interesting. So there's serial numbers. Go to page 1 page and long press the DC power button to view the unit's serial number. Press the C button to navigate through other. When the fault history page, press AC power button for 2 seconds and release the clear history. Okay, UPS feature. So it looks like the UPS feature is enabled automatically. Let's see. I don't even know what to plug into the AC. Okay. Let's plug in this electric heater, right? Let's plug in this electric heater. And let's see. It doesn't turn on. So it looks like we do have to turn on AC. Turn on AC. And turn on this heater. Let's do level That's 600, now it's 900. Now it's 1500 watts. So it's 1300 watts, let's say. And let's see, what if this grid gets disconnected? Let's see, if the grid gets disconnected, does the AC keep working? Looks like nothing switched over. Okay, output. Okay, it's gonna do 0.2 of an hour. And now let's see. Now the grid is connected. Now the input is actually much higher now. It looks like it's taking 300 watts. And the little fan icon just turned on. It's taking 300 watts extra over the top of this because we have the AC on. What if we turn the AC off? Is it gonna go down in the input? I guess it doesn't want to overheat. That's pretty cool. I do like this tactile button. You just press the DC and it's lit up. And then the screen turns off. So even in the dark, you could actually see what's going on here. That's pretty cool. Huh. Now let's see. What can we charge up that's a 100-watt laptop? I don't have 140, maybe 65. So I am kind of liking the 600-watt charging, kind of almost fanless operation, like barely hearing it. That's a good way to charge it up. So long story short, if we turn this guy AC on, it switches over, and let's see, I turn on the heater, and I put it on heater 2. That should be like a 900-watt load. So when it's charging up, it's actually, it looks like it might be taking 600 watts to charge and passing 800 to the heater to keep it powered up. It looks like it just bypasses that electricity straight, the 800 watts from the wall, it passes it through, and then it takes an extra $600, 600 watts, and inputs it into the battery. That's a pretty cool system. Interesting. Interesting. Now let's see what happens if we do both AC and DC charging at once. Is it going to have a higher input? If, let's say, if it's running the output, is it going to have a higher input or something like this? Let's check that out. So now what we're testing out is this. So it's charging at and doing 1400, outputting 800 watts to the heater. And now let's connect a 12-volt battery directly to it and see what power does it go up from 1400s. Now it has the solar panel input icon over here. And now what is it doing? It's still doing 1400 input and 800 output. Okay. How much is it taking from the wall? That's the question. Okay. So we don't know that part. Okay. Let's see this guy. Now, the solar panel icon went away. Now I have this guy over here. This is a 12 to 36 volt transformer. It's rated for 720 watts. So it does 12 volt input and 36 volt output. This is up to 60 volts and 20 amps. let's disconnect the power from the wall, right? So it still does 900 output. Let's turn the AC off, and let's turn DC off. Let's just see how much it charges from this guy, from this 12 to 36. So connecting this 36, 12 to 36, let's see what the charging rate it could do. So with a 12 volt to 36 volt transformer, it's doing 591 watts. That's actually within the limit of this 12 volt transformer. It's doing 600 watts. This one I think is rated to 720 watts. So it looks like we could get 600 watts, and you could use this guy to power this guy. You could use your 12 volt to the 50 volt battery in here. And if we have a 600 watt input, this might be the easiest one, because the standard, the cheaper transformers, this one was like 120 with tax. It looks like at 36 volts is maximum, it inputs a 600 watts. So maybe 36 volts, maybe at 52, it would be more of a closer to a kilowatt. So maybe what it's doing is 15 amps, 15 times 36. I think it's doing like 15 amps and not 20 amps on the input. So it can get the stuff in there. So now let's see if we plug this guy in like this, turning on the AC, turning on the power. So 900 watt output. So technically you could charge it with this 36 volt transformer at 600 watts. See, I have two cables going in here, and I have fuses over here. These are 35 amp fuses to Anderson. So so this is a fused connection to this guy. So because we don't want to over amp it. So output 900 watts. Now let's see if we plug in the AC, does it do more bigger simultaneous charging? I don't think it would. I think it would be maximum 1500. So I plugged in the AC, and now the input went to 1500. So when it's outputting, it's actually getting the higher rate. So here's how I'd probably set up the system. I would probably charge up the 12 volt solar panels, put, like see that MPPT controller, 30 amps MPPT controllers, that's 430 watts. Each one is 430, that's 800 watts that could be going straight to this battery. And then use this up transformer at 600 watts and keep this guy charged up and juiced up at 600 watts. And by having this 1.2 kilowatt battery, I could have 600 watts transform from here to here. And I do have a 54 volt, 12 volt to 54 volt. I might be over amping it though. So then the question becomes, it's doing a combined output, and unless I put it on that meter, I don't know how much it's drawing for the wall. So I'm gonna check out, maybe plug it into the meter on the wall, this wire, plug it into the meter, and see what's going on with how much power. So it's drawing like 600 watts from here. This guy's getting warm. Yeah, this cable is getting hot. Okay. I don't know if it's designed for that amount amperage. Maybe it might be a 14 gauge. So we're not going to be doing this for long. Now let's see when it's charging like this. Let's say it's a 36 volt plus the wall, how much it's using in total. So it looks like it's taking 817 from the wall one is charging up at 1400. So it looks like it's taking 600 from this guy and 800 from the wall to, I think what it might be powering the output at the 800 from the wall, and it's using the solar panel, quote unquote. This simulates a solar panel, a 36 volt solar panel. Basically two 20 volt or 18 volt solar panels in series that are operating at 18 volts. This kind of like summarizes it to 36 volts. So long story short, it is taking the maximum from this guy. And let's see, what if we turn off the AC power? Now it's doing 600 watts input. Now let's see how much it's taking from the wall when the solar channel is connected. It's taking 0 from the wall. So what are we learning from this situation here? That when you have solar connected, 36 volts of solar, it's going to prioritize coming out of this guy first, the first 600 watts. And if you didn't have it set to eco mode, which you could go like this, and turn off the eco mode, turn off the Bluetooth, turn off the Wi-Fi, and then hold this guy down like this. So the charging speed, I think, is adjusted inside the app. If I wanted to, I could go inside the app and have it charge at 1.2 kilowatts. However, perhaps the 600 watt charging is ideal with this 36 volt power supply that I have here. And 600 watts input is probably more than enough that is needed here. And the solar system I'm envisioning is that, think about it like this. A 2 kilowatt inverter minus would probably take up almost as much space and would be half as heavy. And it would be a really, really big box. Like I have over there, that orange box on the wall, that's a 1500 watt inverter. So that's half the size of this. And it has 3 plugs just for AC stuff. But this one, it has the AC plugs. It has 2 100 watts outputs. One of the things I guess it is lacking though is it doesn't have a light. It doesn't have one of those lights. But with these tactile buttons that you could just quickly press DC, that's really nice. Turning the AC on, that's nice. Interesting. This guy's getting a little bit hot. We are pushing a lot of amps through it. And the wire is probably going to be getting hot too. So very, very nice. I'm very much impressed with this unit over here. That is really good. I also like that it's charging up quickly, and it's prioritizing the charging that's coming in from the solar first. And then if I unplug this guy, right, it's going to switch over to to AC charging. And now it's going to charge off the grid. So you could give it 2 power sources, the grid and the solar panels connected. And what we understand from this system is that max input is going to do is 1400 watts. And the first 600 watts, if it could get it from solar panels, is going to get it from solar panels, which is kind of cool. So if we look at this correctly, think about this correctly, is that imagine you had a 600 watt solar panel. So this one operates as a 600. So three 300 watt solar panels, so that even on a half shaded day, you could still get that stuff in there. A lot of those 200 watt panels, they are like 36 volts when they're operating. So technically we could have that operating. And yeah, I do like this. I do like that the AC is only 10 watts an hour. So that's a very efficient inverter. And it could kick in any time. And if you really wanted it to be, you could just have it operate off AC power. I mean, solar power. Or better yet, because the capacity is only 1.2 kilowatts, probably put it into a 12 or 48 volt battery. I do have a 48 volt to 54 volt converter. So what I'm assuming that even because it's set to eco mode and we're not setting it to crazy charge mode, that the 1.2 kilowatt charging mode, that this unit would have been overamped, because this is maximum 720 watts at 20 amps, or it would have just been running at a complete maximum. But because we have the wattage limited to 600 watts, it's running to my benefit, because this 36 volts is not putting too much amps into here. And maybe that's the optimal way to have it charged up, because the internal battery is 1.2 kilowatts. You put a lot less wear if you're doing it at 600 watts. And I do like that it doesn't have, you don't have the Wi-Fi turned on right away. So I do like the ability to turn that on and off. You don't even know how that is important to me. I don't want any Bluetooth or wireless. I do appreciate a separate button on that. That's fantastic. Doug, you do. I do like the input at 600 watts. That's actually pretty cool. And because it's charging at 600 watts, we're having the fan really be the most silent that it could be possible on this unit. So what else do I like about the unit? I do like that the screen shuts off, that it doesn't need there, and these buttons actually light up when you turn them on. So nice tactile buttons, easy to use, easy to plug in. I like that the cords are all plugged in the front, except the AC cord over here, which does have a power reset button on the right side. So there is a circuit breaker power strip inbuilt into the right side too, which is really cool. It does have some sort of screw you could screw into here, that if your grounding plug doesn't have a ground, you could do a separate grounding of this grounding plug to somewhere else. Most people probably wouldn't even care about that. However, probably for safety and security reasons, some people decide to do that. So how would I use this unit? I would use this unit for the inverter, to run a hot plate, to run a coffee maker, because most hot plates and coffee makers, they're at the maximum 1800 watts. 1800 watts is a 15 amp circuit breaker on our standard household circuit for the kitchen. Sometimes the kitchens, they're like 30 amps, so like 3.5 kilowatts at 120 volts, but that's probably within the safety margin. So single at maximum cooking stove thing is like 12 to 1500 watts. So most of the time you are not cooking more than 1500 watts. And if you connected a 600 watt input, but if you connected a 48 volt source, went inside the app, which I'm not going to do right now, you guys could do this on your own time, you could switch it to 1000 watt input fast charging. And this way, if you had, imagine this was, instead of a 12 volt battery, a 48 volt battery. 48 volts would be 52 or 54 volts. You would connect the cable from there to here, from your 48 volt system into here, and then you could expand it infinitely almost. So you could have 10 kilowatts of server rack batteries and use this guy as an inverter, and have solar panels connected through a charge controller like that, an MPPT, and I have the 48 volt always be charged up, 1020 kilowatts. So expansionability, because it can do 1000 watts input, and if you're doing 1500 watt hot plate, you could just have it run for hours. And especially if you put an expansion like this, something like a crock pot could actually work too. You know, the pot where you put things in and it pressure cooks, I think those are maximum 1200 watts. So even though that might, most of the time those don't cook for more than 40 minutes. So you could probably cook dinner on this without it recharging. Or if dinner is over and you wanted to recharge it, let's say it's 600 watts, you could connect a 12 volt battery or a 48 volt. For me, like 12 volt is easier. I understand it a lot easier. If you connected a 12 volt directly to it, it would charge it only 100 watts. So this is a very smartly made system. Okay, friends, it's linked down below. It definitely does get my seal of approval for everything that a solar generator system needs to have. And I already did some tests. The economy mode I turned off because I don't want the AC and DC plugs to turn off anytime. And with it only drawing 10 watts for the self usage, I don't know if it's with both AC and DC on. That's a very, very efficient inverter that they put in there. I only noticed on my inverter because I have a 12 volt through 3500 watt inverter, and that takes a 10 to 12, let's say 12 watts to run an hour. So you probably can't get a more efficient inverter than this one put it in there. So to me, that's the selling point, that this unit is not going to self-deplete itself, even though you turned eco mode off, and then you're running your CPAP machine or your fridge or something like this. You always want it to be powered. But if you're doing the fridge and it's more than 12 hours, you definitely might want to have a secondary battery like this, constantly juicing it up. Even if it's a 12 volt charging it at 100 watts, the fridge takes 100 watts, so it probably would send the first 100 watts to the fridge. So this guy plus a 1.2 kilowatt battery could probably run your fridge for a long time. Or you would be able to plug it into your cigarette plug outlet in your car and recharge it while you're driving somewhere. So let's say it's a 3-hour drive, you could probably recharge 300 watts into it, which is kind of cool, without breaking the system. So this is a very smartly made bank. I gotta say, I'm very much impressed. Very good system.